The high-pressure common rail operates at around 30,000 psi. You have clearances on the order of microns. You have a piston that's injecting fuel on the order of milliseconds, and it's injecting microliter sizes of fuel. So it's extremely sensitive equipment. A lot of examples of mining applications where the trucks will run for maybe 2 hours and they can't pressurize their fuel system because of the amount of wear. Common thing is protecting it. What are the two threats? Very small particles and water. And water will have the same impact through corrosion of the metal surfaces that are in the high-pressure common rail. So the two demands that we're facing are having very small particle filtration combined with very long life, and then also removing the water from the fuel in fuels that are so full of surfactants that it's extremely difficult now to separate water and the fuel. In order to separate anything, be it fuel and water, be it dirt from a fuel, be it dirt from air, what filtration really is you're presenting a surface to that mixture, and by interacting with that surface, we separate the mixture. And one of the most basic ways and the most efficient ways to effect good separation is to have a tremendous amount of surface available. So we have a large effort underway to increase the surface area that is packed into the media that we are using. This media here has thousands of square meters of surface area, and this makes it tremendously powerful for separating water from the most complex fuels that are in our market today, which are fuels that contain high levels of surfactants as well as biodiesel. Racor's media development programs are really quite diverse. We have programs right now that are advancing our knowledge and understanding of the chemical treatments that are needed to give specific chemical reactivity to the surfaces of media. And this is important for fuel filtration, where you're trying to separate fuel and water. So whereas in the past we had particle fibers that were on the order of a micron, we're now pushing down to the micro and now into the nano fiber region. But as the filter dimensions are decreased, the demands for the filter paper are getting more extreme. And so we have therefore moved to composite type media, where if you see here, you have a structural support layer that is giving both structural support and fine particle filtration that is composited with melt-blown synthetic layers, and in this case, this is a 4-layer media, where each of these layers we have designed specifically to marry with one another in order to hold dramatically higher amounts of dirt compared to just the base paper alone. With new fuels today, the differences between water and fuel are not as clear anymore. Now you add surfactants, lubricity additives, anti-wear additives, or biodiesel to that, you shake up that same mixture, the oil and water are very compatible with one another. To effect separation of fuel and water with today's fuels, where there's a lot of surfactants, the water is a smaller particle size and it's much more stable due to the presence of surfactants absorbing onto the surface of the water drops. In order to separate that, the most effective way is to present hundreds of square meters of surface area. And essentially anything on Earth can be separated if you have enough surface area. We want to put, and I'm not exaggerating, hundreds of square meters of surface area between the upstream side of the filter, the dirty, wet side of the filter, and the downstream side where you need clean, dry fuel. And coalescence media that we have developed have thousands of square meters of surface area available per square inch of media for that purpose. Basically speaking, the driver of all environmental compliance of the diesel system is the high-pressure common rail at this point. In 2007, the EPA passed the 2007 on-highway diesel rule. When that was passed, there was a 90 and 92% reductions in NOx and particulate emission mandated and when they were doing their original work to understand, well, how is this going to impact the exhaust systems of the diesel engine, it was considered necessary to have an exhaust after-treatment system that was sensitive to sulfur. Fuel had to drop sulfur, and so there was a 97% drop in fuel sulfur from 500 parts per million down to 10. And that's fine, it's a cleaner fuel, but in order to get your fuel that clean, diesel fuel was subjected to hydrotreating. So In addition, however, to removing the sulfur, hydrotreatment also removed the native chemicals within the diesel fuel that gave it a natural lubricity. In response to that, the additives business responded with tried and true lubricity additives that improved the lubricating capability of the fuel. The lubricity additives, which belong to a chemical class known as surfactants, the surfactants caused water to exist in much smaller droplets and stabilized those droplets in the fuel. So every fuel filtration media that is designed to remove water from diesel fuel was disarmed by this new fuel. So with the introduction of surfactants to meet a requirement for ultra-low sulfur diesel in the end, and puts the high-pressure common rail once again in jeopardy because water is a corrosive element that can corrode the surfaces of the high-pressure common rail. Diesel fuel quality in North America, Europe, and Asia changed quite dramatically in the early 2000s. However, the test standards that are used to qualify filter performance in all of these areas did not change quite so quickly. And it's very important for test standards to evolve along with the market so that products are qualified that are ready for the environment in which they're going to be used. And Racor was instrumental in ensuring that test standards that are used for the qualification of fuel filters reflected the fuel that is currently in the market. At Racor, what we did was we were instrumental in measuring particle size distributions, showing that particle sizes changed. And in addition to that, we were able to show that the methods that the test used to create standard conditions needed to change. We did all the work to ensure that they were changed in that fashion. So of equal importance to the development of media is the engineering of the systems in which it is placed. And that's another major strength area for Recor. Unique media can be combined and engineered into exceptional housings that promote its capability in the field. And a final point on engineering is also in manufacturing. Many of the media that we use at Recor are non-traditional. We develop them and they're unique to Recor. However, not all of them, since they're not traditional, marry well with traditional converting and production methods. Recor is outstanding in their manufacturing engineering, where non-traditional media that enable us to confront today's challenges in the field, those non-traditional media can be converted and manufactured into elements that function and have high levels of durability. So of equal importance to the development of media is the engineering of the systems in which it is placed. And that's another major strength area for Recor. What's going on in the world of air filtration is a sensitivity to fine particles, once again, a sensitivity to wear. So the pressures for media in the air market are increased efficiency, remove more of the small particles. But in air filtration, there's the added caveat that you can't have a whole lot of restriction. An engine, if you want to describe it in its most basic form, is an air pump. You pull air in and you push it out. And any energy that you spend pulling air through a restrictive filter is energy that you're wasting and not using for propelling your vehicle down the road. So the pressures that we have are, how do you make this media more efficient and how do you make it less restrictive? And those are competing interests, because typically in the former paradigm of filtration media, a more restrictive media would give you higher filtration efficiency. You could make the small particles disappear from the stream much better with a restrictive media. We can't tolerate that in air filtration. So in air filtration, we are working with novel base materials, and in addition to that, looking at very small diameter fibers, nanofibers, as a coating on that media in order to scrub more of the small particles out of the air without restricting its path through the media. In addition to that, we're looking at novel ways of converting the media. Now this is a great a great bit of engineering here. This conical shape of the filter actually creates a centrifugal airflow within the housing, and what that does is pulls a lot of the large particles out of the airflow before it ever even sees the media. So what that means is you're getting dirt removal without plugging up the pores and reducing the life of the filter. But there's a whole lot more engineering that we're doing. There are other ways that we can convert the media via different kinds of corrugation and winding and packaging that allow us to shrink its size, increase the surface area, allow us to remove the small particles, and capture the dirt. The diesel engine is the most efficient oxidizer. It's actually capable of oxidizing atmospheric nitrogen to nitrogen oxides. Not many things on Earth can do that. In order to control nitrogen oxide emissions, the diesel engine is made to be a little less perfect of an oxidizer. So particulate emissions in the form of soot are increased and have increased over time as a result of controls placed on nitrogen oxides. Where does all that soot go? If it's not going to be allowed out the tailpipe, a whole lot of it ends up in the oil. So having enormous quantities of dispersed soot in the lubricant has a tendency to limit lube filter life. In order to reduce the amount of soot that's in the lubricant, Racor has developed a bypass lube filter that can dramatically reduce the amount of suspended soot that's in the lubricant, and therefore protect the engine from wear, but then also extend the life of the lube filter that is on the engine. This filter is really very unique. Instead of the standard pleated format, it is wound. It has enormous amounts of surface area for not only soot, but also the lacquers and asphaltenes that you can develop in a lubricant as the lubricant ages. It's wound with multiple layers, and it has, it's a blend of fibers, both wood and synthetic fibers. It's one thing to have sales globally, but it's entirely different to have research and development on a global basis. Although you talk about the world getting smaller because it's becoming more global, but in fact there are very strong differences between local markets. And because we have research and development labs in specific regions of the world, we are better able to understand, anticipate, and remediate specific local issues that arise for our OEM customers. We have research and development facilities in Brazil, Korea, Japan, Thailand, UK, Germany, India, the United States. So it should be fairly clear at this point that in order to have excellence in filtration, you have to have excellence in your media. And that's why Racor invests the investments that it does, both in R&D labs as well as in resources and human resources in those labs to ensure that our media is always on the cutting edge, that it's always the best thing that you can have at that time.